All right, so these are the notes for the second lesson in Chapter 6. Although the first lesson, there's one video, I broke the homework up over 2 days, and I really recommend you approach it like that. That is the sort of foundation for this chapter, and a lot of it you may have learned before in, there's that bell, in grade 9, but I wouldn't rush through that previous part. That's it, assuming you've seen that. Those equations were in what we call slope-intercept form. They're solved for y. It's a really useful form. You can see the slope, you can see the y-intercept, hence we call it slope-intercept form. General form is another way of writing an equation. And in general, it kind of looks something like this, where you have x and y, in fact, everything on the same side of the equation. And therefore, it all equals 0. Bring everything to one side of the equation. And if we're using the variables x and y, we generally write them in alphabetical order, and then our constant is last. Remember, you can rearrange an equation any way you want. And by convention means it's not like a mathematical law. It's just sort of a rule that we kind of follow here on Earth. Whatever is the independent variable, we put first. Whatever is the dependent variable, put second. We always want to make sure a is a positive whole number, and b and c can be integers. Integers, remember, are whole numbers that are maybe negative, but a we try to keep positive. And if simplified, a, b, and c should have only one as a common factor, which means there should be no common number that I can divide out of all of them to make them simpler. That's it. Let me just show you. So these equations here are not in general form. The first one is in slope-intercept form. To put in general form, I need to move essentially everything over to one side. It doesn't matter if it's the left or the right side. And so I'll do that first. And so with this, put in general form, if I just add 5x to both sides, and if I add 1 to both sides, then I'll be done. Because on the left-hand side, what do I have? I have y plus 5x plus 1. I can write those in any order. I'll put the 5x first, plus y plus 1. And that's my whole left side. None of them are like terms. What do I have on the right-hand side? I have nothing. So don't write down nothing. Write down the number nothing, 0. Done. Okay? That's in general form. In this case, it was very easy to put in general form. Now, I will say general form is not so useful for graphing. It's more useful for other stuff we'll do. But in terms of graphing, I actually like the previous equation better, but they're equivalent. And so looking at this next one, I want to put this in general form. So I have a bunch of options. I could distribute the 1/2 in front of the x, but I'm actually going to instead multiply both sides by 2. And so on the left-hand side, I'll have 2y. On the right-hand side, this 1/2 times 2 becomes 1, which means they cancel each other out. And so all I've left is x minus 6. All right, so next I want to bring everything to one side. I want my x to be positive, though. And so I'm actually not going to, you may be tempted to subtract x from both sides, and that's not wrong, but then I make my x term positive. And if you look back at the top, I do say, whatever the coefficient of x is, we want to be a positive whole number. So while it's not wrong, I don't think it's actually going to be less work than what I want to do instead, which is I'm going to leave the x and the take away 6 where they are. I'm going to subtract 2y from both sides. And so on the left-hand side, I have nothing, so 0. On the right-hand side, I have x, take away 6, and minus 2y. I can write those in any order. The convention is we put the x first, the y second, the constant last. And now it's in general form. Notice it doesn't matter if the 0 is on the left or the right-hand side. That's it. And so lastly, for this one here, I already have x positive, so I'm going to keep x where it is. I'm going to subtract 6y from both sides. So on the left-hand side, I have 0. On the right-hand side, I have 3x minus 6y minus 9. And this is kind of in general form, although if you look at the last comment I say here, it says, also, if simplified, a, b, and c should only have 1 as a common factor. If you look at these coefficients here of 3, 6, and 9, I'm ignoring the negatives for a moment because it's really just a 3, 6, and 9 that matter. All of these can be divided by 3. So really, while this is not bad, I really should divide both sides by 3, which is pretty easy to do. 0 divided by 3 is 0. And if you look on the right-hand side, if I divide everything by 3, or if it helps, I can visualize it like this. Divide them all separately by 3. It's the same thing. But if that looks easier, then do that. Then instead of 3x, I have 1x, because 3 divided by 3 is 1. So just x. Instead of 6y, I divide by 3, I have 2y. And instead of minus 9, divide by 3, I have minus 3. So this is in simplest general form. All right, so with that said, general form is not so useful for graphing. It's not useless. I'll show you something in a moment, but it's mainly it's another common way of showing an equation, and it's more useful for things we'll do later on in the course, like I said, algebraic work. But there's a bit we can do with graphing. And in general, if you want to find the intercepts, the x and y intercepts of any equation, it's actually quite pleasant to do with general form, and then we can visualize the graph quite well. So first of all, if you ever want to find the x-intercept of any function, actually, but we're focusing on lines, then you want to go into your equation and you want to substitute y for 0 and then solve for x. It may sound kind of backwards, but if you think about a line, an x-intercept maybe is, let's say it's right here. That point in red, what's the x-coordinate? I don't know. What's the y-coordinate? It's 0. Right? I know what the y-coordinate is. It's something comma 0. So x-intercepts are where your y-coordinates are 0. So it sounds kind of backwards what I said at the top, but it is correct. To find the x-intercept for anything, substitute y with 0, then solve for x. And if you want to find the y-intercept, it's the other way around. Substitute x with 0 and solve for y. So let's do that for this example. So I want to find, let's do the x-intercept first. It doesn't really matter. So if I want to find the x-intercept, I want to make y equal to 0. So I'm going to take my equation, and instead of y right there, I'm going to write 0. So I have x minus 6 times 0 minus 30, which is actually quite pleasant because I don't care how confident or not confident you are with your times tables. I guarantee you're very good at your 0 times tables. And so x minus 6 times 0 is just x minus 0 minus 30, which is kind of silly even writing that step. Why not just get straight to x minus 30 equals 0? Which I can just tell that x has to be positive 30. Or if I can't tell, just add 30 to both sides. And so my x-intercept is 30. And ideally, we can, with a little bit of practice, we can just do that in our head. Essentially, when you make y equal to 0, this whole term here just disappears. And all you have suddenly, and I can see it right here, is just x minus 30. Some number take away 30 equals 0. That's it. Same idea for the y-intercept. I want to find the y-intercept. I want to make my x 0. And so I have 0 minus 6 times y equals 30, which is kind of silly leaving that there. So really all I have is minus 6y equals 30. Minus 6 times something equals 30. If I want, I can just divide both sides by negative 6. And so y equals negative 5. And there's my y-intercept, negative 5. And if I know where my y-intercept is and I know where my x-intercept is, I can visualize the line, because that tells me 2 points. And remember, to find any line, all you ever need are 2 points. And so like I said, general form is not great for visualizing graphs, but it actually is pretty good for finding your x and y intercepts, which allows you to visualize the graph. Just not as good as slope-intercept form. So let's do a couple of examples like that here. Let's start with 4x plus 5y minus 20 equals 0. So I want to find the x-intercept first. Although I could easily find the y-intercept first. Doesn't really matter. To find the x-intercept, I make y equal to 0. So I'm not even going to write that term out. I have just 4x minus 20 equals 0. If I add 20 to both sides, then I know 4x equals 20. Divide both sides by 4, x equals 5. If I did that a little bit too fast, fair enough. Just you may want to show the steps, like you may want to literally show adding 20 to both sides or dividing both sides by 4. I'm hoping, though, we are in a grade 10 academic math class. I'm hoping we can, with a bit of practice, do what I did there, like really quickly, see it without having to write down lots. So my x-intercept is 5. I know this line goes through 5 on the x-axis. So I know it goes to this point right here. And my y-intercept, same idea. For my y-intercept, I make x equal to 0. So the x term vanishes, becomes 0. And so I have just 5y minus 20 equals 0. Add 20 to both sides, that means 5y equals 20. 5 times some number equals 20, y must be 4. And so I can show that right here. And once I got 2 points, I can just grab a ruler, connect the dots, draw my arrows, and I'm done. There we go. There is my equation of 4x plus 5y minus 20 equals 0. that I figured out without actually writing my equation in slope-intercept form. I never found the slope. I didn't solve it like that. I could have. It's just another option. And so if I look at the one to the right over here, same idea. Let's find the x-intercept. And so make y equal to 0, so I get 3x minus 24 equals 0, which means 3x equals 24, which means x equals 8. And again, I'm doing this quickly, mostly just not to bore you with showing you every single little algebraic step. We've done these things a lot, but again, I have nothing against. I mean, if this helps, that takes an extra couple seconds. And if it helps, it's a good use of your time. And y-intercept. Make your x equal to 0, so get rid of that term. And when I look at this, I add 24 to both sides, divide both sides by negative 8, and I have negative 3. And once I got these 2 points, I'll plot them on here. So x-intercept of 8, y-intercept of negative 3. That's all I need. And so a good question is, would it have been faster for me just to solve for y, like we looked at in the last lesson? And that's a matter of opinion. If it is faster, I don't think in this case it's much faster. Honestly, I think what I did was probably faster than solving for y for these last couple examples, but everyone's different. And again, I don't really care about what's faster. I care about just knowing there's more than one way of approaching this. And so I have just 2 last examples, which are in some ways the simplest. If you look at the equations, they're really simple, but you may not be sure what they mean. So this isn't, if I look at x plus 4, this is in general form, but there's no y variable. So what does this mean? Well, I guess I could still start by finding the x-intercept. To find the x-intercept, you make y equal to 0. There is no y, so I just solve for x. X plus 4 equals 0. Subtract 4 from both sides. X equals negative 4. Seems kind of weird, but I can still do it. I just had no y to replace with 0, but still I can do that. And so I know this has an x-intercept at negative 4. Okay, let me draw that right there. All right. What about y-intercept? Well, for the y-intercept, we make x equal to 0. So I get rid of that term, and I have something weird. I have 4 equals 0. Well, no, it doesn't. 4 doesn't equal 0. What are you talking about? 4 doesn't equal 0. So what does that tell me? That tells me that either I made a mistake, or, I mean, it's hard to have made a mistake here. There's not much to look at. This tells me there's no y-intercept. That's what it tells me. So how can a line go through negative 4 but have no y-intercept anywhere? And you may think, well, maybe it looks like this or something. Or sorry, I'll try that again. Maybe it looks like this. Well, eventually, if I continue my y-axis, it will have a y-intercept. So how can it never have a y-intercept and yet have an x-intercept of negative 4? The only way that can be is if it's a perfectly vertical line. And so this represents a perfectly vertical line. And remember, a vertical line has a slope that is undefined. And that is what this line must look like. If there was if the slope was any different, at some point there would be a y-intercept. And notice the simplicity of the equation. The equation, especially if I write it like, if I take this equation and minus 4 from both sides, if I write the equation as x equals negative 4, it's literally visualizing this line I see right here. If you look at this line exists only where the x-coordinate is negative 4, whether it's above or below the x-axis. All those points on that line have an x-coordinate of negative 4. And every time you have a vertical line, all you need to know is the x value, which makes sense. If I'm going to draw a vertical line right there, if I'm going to describe where it is, I just need to know how far over to the left and right. In this case, it's like 7.5 or something on the x. So anytime you see an equation with just x, it's a vertical line, which means you can now perhaps immediately guess that, or know that anytime you see an equation with just a y, it must be a horizontal line. And I can do the same sort of thing here, where I solve for y. In this case, because I've already kind of done this once, I'm just going to add 3 to both sides and write it as y equals 3. And we actually saw this in the last lesson. So there's a y-intercept of 3. But there's no x, which means there's no slope. Or I could write, if I want, I could put plus 0x. That's not wrong. My slope is 0, which means it's a horizontal line. Or, I could You know, I could also make a table of values, but at this point, once I know it's a horizontal line, once I know the slope is 0, once I know it's going through 3 on the y, why waste my time making it any more complex than I have to? And there we go. Essentially, this equation, or this equation, which is maybe a bit nicer to look at, just means it doesn't matter what the x value is, y is always 3. And if you are visualizing a graph, a two-dimensional graph where the x number can be anything, but the y coordinate's always 3, it's going to look like this. And so remember again, it's easy to mix the two up. Anytime you see an equation with just an x, no y, it's a vertical line. And anytime it's just a y, no x, it's a horizontal line. Really, really easy to mix up. But hopefully this kind of makes sense. Okay, the simplest equations I gave you today, simple as graphs, just vertical or horizontal, but really, really easy to mix up. And that's where I'm going to stop. So that finishes the lesson, and thank you.